your job to read that to everybody on the board, just in case like maybe Samuel can't handle it too early in the morning for him to read that much or something.
It's too much for me to do.
I was counting on you. This be too much for you. Levi, you ever see your uncles?
Not very often.
Where's Rob live at now?
St. Paris area.
What's WA?
Worksheet. St. Paris, St. Paris. Trying to think where he lived that last time I talked to him. Like he lived, didn't he used to live down off, he like lived right off the interstate, off 70 or something?
Yeah, for a while.
It's like this big house off the interstate.
I totally forgot my calculator. I have a calculator.
Nobody said nothing stupid, did they?
Yeah, it doesn't work.
How to use a ruler. I know some of you are going, oh my God, yeah, we already know how to use a ruler. I'm not going to say anything sarcastic here. With the centimeter side, this is the centimeter side. Each whole number is a centimeter. Each of the little marks is a millimeter. All right? We're going to measure, I know your paper says measuring in millimeters. We're not going to measure in millimeters, we're going to measure in centimeters on this one. Okay? I'm going to explain to you how to do centimeters and millimeters, but we're going to do it in centimeters. If I have, a lot of times you'll see a segment represented something like this. It'll have a starting point. It'll go out somewhere. And then it'll have an ending point, something like that. So if we're trying to measure just that on the centimeter side, what you do first, you count out how many whole numbers you went past. So this time we went out 4. You can go home, yell at your parents tonight, because there's no doubt that the United States should be completely on the metric system, not with the standard system. And it's their fault that we are on the standard system, not the metric system, because when Jimmy Carter and those presidents back then wanted to change over, everybody threw a big fit. Because, oh, it's too hard, we got to learn something new. No, the metric system is 1,000 times easier than the standard system. So when I'm doing this, all you got to do, count out, whole number, put a decimal, and then you count how many spaces you went out. So I don't count lines, count spaces. So when I'm starting here at 4 and I move, 1, 2, 3, 4. It looks like I'm out 4 extra spaces. That means I put a 4 right there. So that segment would measure 4.4 centimeters. Devin wants to be a gung-ho math person, be ahead of the schedule, and he says, well, I want to write it in millimeters also. To change this into millimeters, this is what makes the metric system so much easier. all you gotta do is bump that decimal over one place. So instead of 4.4 for millimeters, it's 44. Yes? Sure. So 44 millimeters. You really don't need this. This is the answer I want to see on the paper, 4.4. Jesse, you need to grab that stuff up here. Sorry. I should have told you that when you walked in. Grab a ruler, a paper ruler, and the worksheet. Flip it over to the other side just real quickly. On the other side, you're measuring in inches. In inches. Some of the rulers, I never seen this before on some of them though, and I probably need to explain this. If you look at the end of your ruler, it actually says start here. That always kills me when they put stuff like that on this stuff. It's like when they put warning labels on the back of boxes, because to give Caleb a box of cereal and they got to put a warning label on the back of it not to eat the cardboard that the box is made out of or something like that. This is sort of one of those things, the dumbing down of America. They think that you're so dumb that you don't know to start here. All right? Does anybody know why, besides that, why they put that here, a black line where you start at? Do you start at the end of the ruler? No, it used to be on the old rulers back in the dinosaur days when I was sitting in class here in school. We had those rulers where you started at the very end. But just like some of you probably, Mr. Evans will sit here with Mrs. Evans' rulers and did stuff like this. And what ends up happening to the end of it? Gets all messed up. And then after a few years, with those old wooden rulers, the end's no longer active. So now they start the ruler in just a little bit so that that end can't be messed up. All right? So make sure you're starting at that black line. Don't start at the very end of the ruler. Start at the black line on centimeters and on inches. I never noticed that though until just yesterday that it says start here on these rulers. I thought, Hayden knows where to start on this ruler. He doesn't need you to tell him to start here. That's ridiculous. So we're starting here. If we want to measure something on this one, watch on the inches. This is the one everybody has trouble with. We want to measure that segment. You sort of do the same thing as with the centimeters. 1, 2 whole numbers. Bad thing with the standard system is no longer is it in decimals. Now it's fractions. Which one does everybody like better, fractions or decimals? Decimals by far. Everybody hates fractions, right? Fractions harder to deal with. You got to put more work into them. Got to use fractions on our standard units. All we do, and what I want you to do right now on your ruler, pick any 2 inch marks, any 2 consecutive inch marks. So maybe Kelsey picks 2 and 3. Maybe Morgan picks 5 and 6. I don't care which 2 you pick as long as they go right in order. 5, 6, 7, 8, whatever, whichever ones. And I want you to count the spaces in between those 2 inch marks. And I want everybody to do it. Count those spaces. How many spaces? Not how many lines, how many spaces are between those 2 inch marks. Ms. Deerdorf said 16. Anybody else get something different? Because you guys are all, this is my smartest class, right? So nobody wants to say anything different because they know that's probably the answer, right? Sure. When you're doing inches, the only way a ruler that's in inches could be split up is by using one of these numbers I'm getting ready to write up here. It could be split up into 2 parts. It could be split up into 4 parts. It could be split up into 8 parts. Could be split up into 16 parts, which that's what kind of ruler we have here, and the kind of ruler that you'll probably use most of the time, ones that are split up into 16ths. It's also, if some of the young men maybe are helping your dad out measuring something at home, if you look at a tape measure, the first 2 or 3 or 4 or 5 inches might be split up into 30 seconds. So they go even little smaller gaps than these. And it might also even be measured in 64ths. If you work on cars a lot, you might have a caliper or something, caliper that measures real small measurements, so that maybe you can measure the size of your piston to make sure it's the right size. It hasn't been expanded or smashed or something. So you might have something that goes down in 64ths, 128ths, so on and so on. Most of the rulers that we have will be 16ths. All you do, once you get your whole number, we know our bottom number is going to be 16 every single time. All right, so you get your whole number, and then you count spaces out to the end of the segment. So count for me.
1, 2, 3, 4.
So what goes up top here? Now, what do we do with that 4 over 16? Reduce it. What will go into both 4 and 16? Okay, you could divide by 2, then it's going to reduce again. Somebody said divide by 4. That's the easiest way to do it all at once, right? How many 4s are there in 4? 1. How many 4s in 16?
4.
How long is my segment? 2 1/4 inches. Ignore that stray mark flying up through there. All right? Think you can handle that? Got a few minutes while I do attendance and stuff. Make sure on both sides, put your units. On both sides, when you do your measurements, put your units. So on the first side, put centimeters. On the second side, put inches. Answer on each one. If not, don't be afraid to stop me and say, how'd you get that? And we'll go through it. Again, make sure you're putting your units. Anything, and you should have math teachers all the way through your whole educational career telling you every time you do something, put units with it. On the first one, whole number, we go out past 1. So we got 1. We're just doing a metric system, so point, how many extra spaces did we go out? About 1.5 centimeters. Is that what everybody got? Now, if you, seems like I seen somebody who had 1.4 centimeters. You think I would mark that wrong? Probably not. All right? As long as you're close. Now, the bad thing with me saying that, as long as you're close, is somebody's going to say, well, 1.3 is close. I'm going to say, no. There's a certain range you got to be within. And on these rulers, for our centimeters, the precision of this ruler is down to the nearest millimeter. So 1 millimeter. So if I say it's 1.5, then you should be within 1 millimeter one way or the other. All right, 1.4, 1.6, somewhere in that range. On the inches side, what did we say the smallest space was on this inches side? One of those little spaces counts as how much of an inch? 1/16, right? 1/16. So that means the closest we can get is to the nearest 16. So if you put down, I have it over there, if you put down 5/30 seconds on something you measured on here, this ruler won't measure that precise. It only goes down to the nearest 16th of an inch. All right? Next one. Looks like we go out about 1.7. Everybody agree with that? Next one. What'd you get on that one? 14.2. You got 1? 14.1. Is that pretty close? Yeah, either one of those is probably acceptable. Let's go back to this. How many millimeters would that be? 142. Now what I want you to do, take a second, take your ruler, and I want you to count how many little spaces there are from here to there. I'm just kidding, don't do that. There's 142 of them, right? That's why we set it up this way, so we don't have to count all those spaces. Next one. Get exactly 3 centimeters. Next one. Now, I gave you, before we go on, I told you to grab the paper ruler, then I didn't have you use it. On the paper ruler, and please make sure these get back in the box if you grab them, because I found a whole bunch of them on the floor. The reason I passed this out, I have 3 sons, and I grabbed a tape measure the other day to measure something. And the end of the tape measure was all messed up. You couldn't read it anymore because one of them had done something to it, whatever. I don't know what they did to it. I didn't bother to ask. But they tore up the end of the tape measure. So when I grabbed it, and I'm lazy, I didn't feel like walking back in and grabbing a different tape measure. So I just started measuring from like the 4-inch mark. Now when I measure that, let's say I was measuring out to right here. Am I going to say, okay, I'm at 9 1/4 inches? No, because I started at 4. And a lot of things you won't always be able to start at 0 to measure. And that's what these are for. That's why they're sort of cut off. All right, sometimes when you measure something, if I was going to measure this, I might start at that 4-inch mark, or I might start at the 3-inch mark, or 5-inch mark, or whatever. So you can start anywhere on the ruler. You just have to remember that that changes the way you're measuring. All right? And that's the way I set this one up. I started at 6. I'm not going to say, okay, this is 9 and 9.9. That's not going to work. So all we do is count the centimeters. 1, 2, 3, 3 whole centimeters, and 0.9. Is that what everybody got on that one? So the whole purpose there is just to show you that you don't always have to start at 0. Somebody got 8?
I did.
Is that pretty close? Next one, I start the same thing. How long did you get on the next one? 6 centimeters. Next one, 4.1. How many millimeters is that again? 41. 2.5. On the inches side, a little tougher on the inches side. As I walked around, the first thing I noticed on the inches side, a lot of people don't like reducing. Nobody likes fractions, nobody likes to reduce. You gotta be able to. Here, we don't even go out past a whole inch. We count the spaces. Don't count lines, count spaces. So it's like when I start walking, do I count 1 right here? If I'm gonna count my steps, when do I start counting?
After you take the first one.
After you take the first step, that's 1.
2.
2. Same thing on here. You count 1, 2, 3, 4, 5, 6. You count spaces, not lines. So it's 6. What do we say the bottom number is always going to be for this ruler? What do you do with that? Where people have trouble with reducing, you got to ask yourself what will divide evenly into that. And as soon as I ask this question, every class that I've ever had, they say 3. Now 3 won't divide evenly into both those, but what they're thinking is correct, because what they're thinking is I'm going to divide 2 into 6, and it gives me how much? 3. You're actually dividing each one of these by 2. So you're going to divide each one by 2. How many 2's are there in 6?
3.
How many 2's in 16? 3/8 of an inch. Again, anytime you're in inches, in our standard system, one of these numbers has to be your denominator. It has to end up as your denominator. It can't be anything else. Next one. What'd you get on this one?
4.
4, exactly. Brandon, that's what you got?
Yeah.
Very focused, my friend. Next one.
5
Which one you want?
Oh wait, go back.
1 inch. Next one, now Sam,
5
5
1/4.
1/4. Anybody else get that?
Yeah.
It was 5 4/16. Reduce 4/16 down to 1/4. 5 1/4 inches. Next one, again, I start this one somewhere other than half. Now some of you, if you get good at using a ruler, you might realize, or a tape measure, whatever, these marks are different size, or different sizes, and they're different sizes to show you, like this right here, the longest one, well actually the longest one is the 1 inch or 2 inch or 3 inch line. Next longest one is the half. Next longest ones are the quarters. Then you have your eighths, and you could use that.
So like what you're trying to show is since like we have a measurement on one, still like measure on any part of the ruler.
Right, you can use any part of the ruler. You don't have to always start at 0. But if you don't start at 0, make sure you don't do this and say that that's 2.5 inches long just because we went out to the 2.5 inch mark. Okay? You'll get a lot of times, I know I have several at my house. I have like a square or something, a carpenter's square, and it's either broke or it's so old that it's rubbed off on one end or the other. So when you go to measure, you might need to start in the middle, and you should be able to do that. Shouldn't be any harder than measuring starting from 0. Next one, how long was that one? Everybody agree with 3/16? 7/8. Anybody else get that? Was that a hard one? Caleb, was that a hard one? Oh, did I skip one? Oh. How do we figure out if this is 7/8 or not, just to make sure whoever told us that's right? Just start counting spaces, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Does it go out to the next one?
I got
13. So 13/16. Somebody else said 7/8. What would 7/8 be? 14/16. That'd be out that one extra space, right? Would I probably accept either one of those two answers? Yeah, probably so. Those are pretty close to each other. Even though you look at these numbers, 7/8 and 13/16, and you think those are two completely different answers. Well, they're real close to each other. All right? So you got to know how these numbers relate to each other, that they're not really all that far apart, even though the numbers look like it. Is that why everybody was quiet on that one when somebody said 7/8? Because the 13/16 was what everybody got, and they thought, well, I must be way wrong then. Yeah. How about this one? 3 inches? Is that the last one? Yeah. All right, set the rulers off to the side. Something I didn't say with you guys because I didn't think I had to say it with you guys. The rulers, if I have a white one up here, some of the white ones, you can really see it. If you have one, or the clear ones, I mean. If you have one of the clear rulers, I don't have any up here. If you look right here in the middle, a lot of them, you can see a crack right there. Any idea why that crack would be there? People doing this. The school did not buy these rulers for me. I buy them because I just don't figure if you guys pay enough fees, I can handle going out and buying $30 or $40 worth of rulers for my classes if I want to use them. All right? So anytime I give you rulers, protractors, compasses, please take care of them. All right? Don't. Last year, as I was making this speech in the very first class last year, when I was making this speech, had a student sitting about where Jesse's sitting, and I'm going, please take care of my rulers. And guess what I heard? Snap. No kidding. I'm like, you know, right at that point, one of the few times as a teacher I ever wanted to actually cuss. And I said, are you freaking kidding me? To the young man that did it. Because he was sitting there, like, flipping it or something, and it snapped. So just take care of stuff. Set the rulers off to the side. We'll put those back up here in a minute. Open up your books to page 8 in the homework. Each day, when you come in, I'll ask you for questions on the homework after we check it. You all right on that? You highlighted?
Yeah. I have it, but I can't hold it. So I have something that I must have.
Questions, problems you want to see me work off of the homework as you ask these questions. Don't be afraid to ask, all right? Even if you think you got it right and you just want to know for sure, ask. Even if it's just the fact that, especially later on in the year, you want to see me draw something just because you know my drawings will be ugly and you'll be able to laugh at them, that's fine. Yeah, Colin.
Page number 84.
84. I put it somewhere. Okay. Did I give it to somebody? Just use this one. I think somebody took it. I think somebody in my next class said that they had class with you, so they were going to give it to you. I'll have to figure that out. Questions? 16? 16. Name a point. I'm sorry. Name one pair of rays that are not opposite rays. Let's see if I can do this. Nope. So I don't have to draw. Sort of see those. 16 says, name one pair of rays that are not opposite rays. Not opposite rays. Let's name a pair of rays that are opposite rays. Pick me a ray in this picture. Anybody? ED. Everybody see ray ED. Starts here and goes out that way. Remember when you name a ray, 2 letters, symbol above it, what would the opposite ray for that be? One that goes in the opposite direction. E what? EB. I have to go out that way. So that would be 2 opposite rays. Now they want 2 rays that are not opposite rays. So we can't pick EB. Let's pick ED here. What's another ray that would be not an opposite ray for that? AC? EC? That would work. EC goes out this way. Those 2 rays aren't opposite rays to each other. Now I said AC. Would AC have worked? that array? Yeah. A lot of you get confused because you think, oh, array has to start right here. Does it have to start there? No, it could start anywhere. So this ray could go from here out that direction. Be sort of hard to name an opposite ray for that one because we don't have the correct letters and stuff on there, but rays could start anywhere. Something I forgot to do. We were going to go around the room and ask to name something. Let's do that real quick. And since I messed up and forgot to ask anybody, I'll just take the volunteers. Somebody raise your hand and name me let's do a plane first. All right, Levi?
Floor.
The floor. All right? Name me a point in the room. This is probably the hardest one. All right, Colin? Don't say a point that I drew on the board either. He was showing you something. No, he's showing you.
Oh,
His fist, right?
yeah. I was just gonna say grenades.
Now, let's use the room without the fist. Anybody, name me a point somewhere in the room that you could use for a point.
Peyton's head.
Peyton's head.
What?
Be nice, Peyton. He didn't say it was like a giant point or anything. You have a melon head or something. How about the corner? Would the corner up there be a point? Yeah, that's probably the easiest one. Name me a line in the room. Right? Peyton. The line up top of the chalkboard. Now, is that actually a line? No. So name me a segment. Could you name the same thing that Aiden named for the line? Yeah. But if in Aiden's world, if he wants it to continue on forever, could it? Yeah. That's what we do with lines. We can't actually show them. Name me a ray. Everybody's always stumped on this one. All right, Mike. The clock hand. That's a normal thing because it's got an arrow on it, and everybody thinks, oh, so that's got to be a ray. Let's go back to Aiden's top of the chalkboard. Could we make that a ray? Yeah. Could I say we start right here and we go out that direction forever and ever? Yeah, just like you could make it a line. So don't let rays and lines. Just because a picture shows you, like if I'm looking at this picture and I see, hey, that's a line right there. Could it also be a ray? Yeah, start here and go out that direction. Could it also be a segment? Yeah. Anytime you have a line or a segment or a ray, you could have all the other ones too. Are there other, I did this one, are there other rays in this picture that are not opposite rays? Yeah, a whole bunch of them. I'm not going to list them all. Next question. Go ahead, Colin.
You're 17.
17 says, sketch the figure described, plane P and line L intersecting at one point. I think I have a plane P right here. Can I consider this marker a line? Yeah. So I got plane P. I got my line. Do I want it to look like that? How many points is that line intersecting the plane at? Not one. Is it intersecting it at this point? This point? This point? This point? This one? This one? This one? How many? All of them, right? Is that what we want? No, we want it to intersect at one point. Take my line there. Show me how your line can intersect my plane at one point. So everybody agree with that? What's it doing to the plane then? It's like going through it. So if I had to draw that, draw my plane, put the P, remember capital letter P in the corner, for the plane, how am I gonna show the line? So it goes through, we'll say it goes through right there, who knows where it goes through. Looks something like that. Now, what do I have to show so that everybody knows that, hey, this isn't just laying? So from here, we want it to be dotted or dashed, right? And then once it comes out the other side, then we go back to making a solid. What line was that? Line L. So we put, remember with the lowercase letters, you put the letter out there beside the arrow. Have the imagination, Kelsey, to see that line coming out, even though my picture isn't very good. I need to get Mrs. A in here to draw three-dimensional stuff, don't I? She'd probably do a little better job. Other questions? 27? Which one you got there? 24. 24? Let's do 24 first since it's right here. That's another one of them sketching ones. Good for me. 24, plane C and plane D intersect at line XY. I think it was you guys. Did you guys teach me how to show these two planes? Or was this the class that said, hey, I learned something? We got two planes and they intersect at one line. What's it going to look like? When you guys that showed me this? Maybe not.
It's gonna look like the.
Like the book, right? So if you hold your book up, where's my line at? Down the center, down this crease right here. This over here is one plane, this over here is the other plane. So it's going to look something like this. If I was to draw it, I'd probably draw the line first. What'd they say the line was named? XY. So I put an X, it's a point on the line, put a Y, it's a point on the line. One of my planes maybe looks something like this. The other plane looks something like this. So you got those two planes come together. In the past, I always tried to do this. I always tried to draw a plane, then draw some other plane and make it look three-dimensional. And some of you might be able to do this. I can't. Make it look like it goes through it. Yeah, that's horrible. Somebody yesterday showed me a drawing that was very, very good. This is probably the easiest way. You got your two planes, they come together. Right there where my hands are touching, that's where your line would be. Could think about the wall and the floor. Two planes come together. That black strip there is the line where they intersect. Did they name the planes? 24, C and D. So what should I put on this blue plane? What goes in the corner? C, D, and the other one. Yeah, that's why it wouldn't go up in there. 27. Name a point that is collinear with points E and H. Got point E right here, point H right there. What's collinear mean? Same line. Same line. What's coplanar mean? Same plane. Same line, same plane. So collinear. Name me a point that's collinear with E and H on the same line. J. So point J. Now where a lot of people have trouble with this again, they look at that and they say, well, there's no lines in there. Can that be a line if I need it to be for whatever reason? Yeah. You gotta be able to use your imagination, even though that side is a segment, we could make it a line if we want it to be a line. Next question.
For number 46, since the points are on the corner, does that mean that means that each point is on 3 planes, right?
Is it possible for one point to be in two different planes? If I look at Y right here, we drew this a minute ago, right?
Well, I mean on the cubes, points look like they're on the corner, so does that mean that?
Yeah, it's so same thing. All right, so if I look at Q right there, is Q in this front face, which is our plane? Is it in that face right there, that side? As a matter of fact, it's also in that bottom plane, isn't it?
Yeah.
So just like the corner of the wall. If I look at that corner up there, is that corner part of the ceiling, part of the wall, or part of this wall? It's all three. It's actually in all three.
That's the floor.
Huh?
The floor too, ain't it?
Not that point, but if we picked the bottom corner, then yeah, it'd be part of the two walls in the floor. Let's hope that point's not part of the floor too, because then we would all be crushed by the weight of the ceiling falling on. Other questions? Ready to move on? Everybody understands it. We have a quiz next time, and I tell you that you got to name these lines and rays. You're going to be able to do it. Everybody knows what symbol goes with what, how many letters to use on each thing. Now you can set the books off to the side now. On this, look up here. I grab my yardstick. I'm going to have Ricky come up and measure this line. And as Ricky's walking up there, because you guys aren't mean people like I am. As Ricky's walking up there, what are you going to tell him? They're mean people, Ricky. They're just going to have you come up here. I have him come up here to measure this line. Goes on forever, so what can he not do? He can't measure it. So somebody would tell Ricky before he got up here and started measuring it, and Mr. Eversole's having a good laugh at his expense. Ricky, you can't measure that because it's a line. How about this one, this ray? I have Devin come up and measure this ray. Is he going to be able to do it? No. This segment. That we can measure, all right? When we're looking at these names, very important that you understand this before we go any farther today. What's this first one? Line AB. What's that one? Ray AB. How about that one? Segment AB. All right? How about that one? You don't know, do you? They didn't put a symbol. Again, math people, extremely lazy. If you don't need something, they're not going to write it. They're not going to put it on there. When you see this, when you see something with two letters, it's either naming a line, array, or a segment. Every time it's got two letters, it's got to be one of those three things. You see the one that doesn't have any symbol, so you think, well, what is that? It's always going to look like this. It'll give you something like that. Now, once we have that, is AB that we're talking about this time, is it a line, array, or a segment? gotta be a segment. Why? Because apparently we measured it. And we can't measure lines and we can't measure rays. So when you see two letters without a symbol, it's gotta be a segment. Alright? Now does that mean every time you name a segment, I just want you to write it that way? No. If we're not giving the segment a length or a measurement, you have to put the symbol. But if you're giving it a measurement, then everybody knows that that has to be a segment. So math people again are lazy and they say, we don't need that segment symbol there because Maverick knows it's a segment because we measured it. It can't be a line. It can't be a ray. Now if you put that segment symbol up there with the measurement also, I probably won't mark that wrong. But if I ask you to name this segment right here, and you just name it QR, that I will mark wrong. Because if you're just naming it, you need that symbol. Alright? Does everybody understand that? So that's sort of unnecessary. You don't need that symbol on there if you're giving it a length. Anytime you see that without the symbol, then you're going to know it's a segment. Alright, go ahead and start copying this down. As a matter of fact, let's get that. Let's copy that down. Maverick, you have trouble from back there seeing all that light blue and yellow and orange and stuff. I need to quit using all those colors, don't I? Just use black because it's hard to see from back there. Huh? It's not fun. Oh. Yeah, but if you can't see it, it doesn't do any good. Make sure you get the binder if you haven't already. See John here, he's got his binder, he's writing his notes right there in his binder. Everything's going to be right in order. Wherever he's got his notes at in there, he's writing them right in there so they stay right in there. Easy grade. This first definition, this is the word we're going to use, postulate. Postulate, axiom, and corollaries are all basically the same thing. And we're not going to talk about what little differences there is between a postulate and an axiom or a corollary. Very easy to remember postulates and theorems. Those are the two that you need to remember. A postulate is a rule that you take for granted is true. So anytime I tell you a postulate, you just take it for granted it's true. Alright? You can't ask me why. So when we're dealing with a postulate, you don't say, well, why is that true? I don't know. You just take it for granted it's true. Joe's talking to his mom or dad, and he says, well, why can't I go? That's questions you don't ask your folks, right? I don't know, maybe your guys' folks are different than mine. maybe you're different, your folks are different than me, because my sons know they don't ask why. Why do I have to do that? No. And if they do ask me, they're about where Colin's at from me. Because they know if I can get a hold of them, they're in trouble. So that's what a postulate is, something we just take for granted. That's the way it is, who knows why. Jesse, back in first grade, his teacher told him 2 + 3 was 5. Did you ask why, Jesse? No, you just took it for granted. 2 + 3 is 5. Because that's what the teacher said, right? That's sort of a postulate. We just take it for granted it's true. A theorem. When you draw this box, I wouldn't draw all those lines. You guys know how to draw a X and Y axes, right? Probably did plenty of them last year. Didn't have to be pretty. A theorem is a rule that has to be proven true. Something that you have to prove is true. So Pythagoras, many years ago, he had to prove that his theorem was true. Postulate, we take for granted is true. Theorem's got to be proven true. When we're dealing with coordinates, somebody tell me the coordinates on this number line of that point that I put on there. What's the coordinate of my orange point that Maverick probably can't see? That's your answer, 6, right? If you're on the number line, you're one-dimensional, you just pick that coordinate, 6. How many coordinates do we pick if we're on this coordinate system? 2. We have an X and a Y. X tells you how much to move left or right. Y tells you how to move up or down. You always move left or right first, then up or down. A lot of you, because you did, and I guarantee when we take this first test, because you did slopes last year in algebra a bunch, a lot of you do the X and Y backwards. Please make sure you don't do it backwards. I guarantee on the first test, out of a class this size, there'll be about 8 or 10 of you. I'll put this point on here, and I'll say graph it, and it should be an easy question on the test, and about 10 of you will miss it. How do I graph that point 5, 2? You go to the right 5, up 2. Okay? Left or right first, then up or down. What's this point called? Origin, good. Origin, you might want to write that in there. Does anybody remember which quadrant this is? 1, 2. It goes counterclockwise, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. I put these on here just because it seems to help people sometimes. In quadrant 1, the X and the Y are both positive. In quadrant 2, X is negative, Y is positive. Quadrant 3, they're both negative. Quadrant 4, the X is positive, Y is negative. Everybody remember all that from last year? Just a lot of review here. Thing I wanted to show you here though, when we're talking about a coordinate or coordinates, if you're on a number line, one dimension, one number. If you're on this plane, 2 numbers. The ruler postulate, before you write this down, the ruler postulate says something like, I'm not even sure what it says. If I have their book laying there handy, I'll read this to you. And then, so before you start writing, points on the line can be matched 1 to 1 with the real numbers. The real number that corresponds to a point, it is the coordinate of the point. The distance, that right there was the ruler postulate. Anybody understand all that? Origin. Good. sort of a bunch of garbage, right? And I'm going to tell you what the ruler postulate is. The ruler postulate just shows you how to use a ruler. It tells you to match up one end of your segment, or one end point of the segment with the 0 on the ruler, and the other end tells you the length of the segment. This, the segment addition postulate, please make sure you write this down. Very important. Guarantee on your final exam, there's probably 3 or 4 problems that deal with the segment addition postulate. Very important, so make sure you write that down. Again, I didn't check them today. I told you to have them this week, calculators. I will check them next time, so make sure you get a calculator in between now and next class. They will be checked, I promise. This time I'm not lying to you. Sometimes I will lie to you. This time I'm not. They will be checked. Have a calculator by next class. Even if you borrow one off somebody else. Not somebody else in this class. I don't want John passing his calculator over to Peyton as I'm walking checking calculators, and the calculator ends up way over on the other side of the room because everybody used it. That's not going to work. Segment addition postulate. If B is between A and C, now I'm going to explain to you what between means. If I'm looking at this row right here, Michael, is Michael between me and Joe? Yeah. Does Michael have to be right in the middle to be between? No. All right? Then if I'm looking at something like this, is Daytona, I had to think for a second. Is Daytona between me and Caleb? Yeah. Right? Is Maverick between me and Caleb? No. So for between, this point B has to be on the same line. You can't have some point out here and say D's between A and C. Right? For between, it's got to be on the same line. It's got to be collinear. Doesn't have to be right in the middle though. This segment addition postulate says this. If I walk from A to B, I stop and take a break, and then I walk from B to C, how far did I actually walk? From A to C. Alright? So what it's saying is, this segment plus this segment, those two added together have to equal what? That whole thing. That's all the segment addition postulate says. So if I told you this part right here was 6, and I told you this part was 10, what could you tell me about the whole thing, segment AC? It's 16. This segment plus this segment has to equal the whole thing. That's all the segment addition postulate says. But then you also got to understand that B is between A and C. Well, B has to be on that line somewhere, but it doesn't have to be in the middle. All right, it's got to be on that line, just on it, anywhere. Write this down. We're going to draw this picture. Just write that top one. We're going to draw this picture and use this as an example. gotta be able to draw these pictures as we go through this. I go to draw my segment here because I know I'm dealing with segments because they have links. So they're not lines, they're not rays. LM's got to be a segment because it has a link. When I go to draw this, I draw some segment. How many points do I need on that segment? How many different letters do I have there? 3. All right, I sort of heard 6 come out. But are those two different? Those two different? There's only 3 different letters, right? So those are the letters I need. So I put 3 points on here somewhere. And then you got to figure out which one goes here, which one goes here, which one goes here. Which one do you think is going to go here? Make a guess. 1 point, right? So here is what? Just L. What do you think is going to go next? M maybe, then what? R. I don't know if that's right or not. We'll find out here in a second when we go to label it. They tell us segment LM is 12, so I put 12 in there to label it. From L to M is 12 units long, whatever that, whatever units we're using. From R to M, 3x plus 3 units long, right? And L to R, when I mark this, because it's sort of hard to mark, you might have seen your grandpa or your dad or somebody do this at some point on a drawing. When I mark this, I put these little bars and then put the number in between. That tells me it runs from here to here, and that's how long that whole thing is. Does that make sense the way our drawing looks? This is 12, this part's 3x plus 3, the whole thing's 63. Does that make sense? Yeah. Now once I have all that, what you're going to do is set up an algebraic, hopefully you remember stuff from last year, you didn't forget quite everything over the summer. You're going to set up an algebraic equation using the segment addition postulate. This segment plus this segment should equal the whole thing. So what equation can I set up here? What's my first segment? 12 plus 3x plus 3. This plus this equals what? The whole thing, which is 63. Everybody see where I got that? Hey, doesn't that make any sense? This plus this equals the whole thing. You set up that equation every time. Is this an equation we can solve? Anybody remember from algebra how to solve that? What's the first thing you do? Combine like terms. 12 and 3 give you what? 15. I'm going to put 3x plus 15. Doesn't really matter which order those are in. Subtract 15. You end up with 3x. These cancel out. That's 50, or oops, 48, sorry. Divide by 3. We end up with x equals what? How many 3's are there in 48? This is where you need the calculator, right? 16. Are we finished? Last year in algebra, that's probably where you'd stop. This time they ask us to find RM. What's that saying? Find the length of segment RM. So we look back up here, RM's right here. What are we going to do right here where we see x? Plug in 16. We now know x is 16, so we plug in that 16. 3 times 16 is 48 plus 3, 51. Now some of you figured out already because I heard you mumbling. On this certain problem, could we have found RM before we ever found x? Yeah, because if this whole thing is 63 and this part's 12, what would you do to find just this part? Subtract those two. And That's why they asked you to find both of them, because they actually wanted you to find X and Rm. Either way, we would have had to set up that equation. Looking at this one, just watch and help me out. I draw my segment. Ignore that stray mark there. Again, I'm going to have 3 points, but this time they tell us T is what? Midpoint. Where do you think the midpoint's going to be located? Far right, clear over here. Midpoint, what's that mean? Middle. Midpoint tells you it's exactly in the middle, so it's going to be right here somewhere. And if it's a midpoint, what do we know about these two parts? They're the same. If I start walking here and walk to right there, Miss Deerdorf starts walking here and walks to right there, who walked farther? Neither one. We walk the same. To show that in this picture, you can use little tick marks. And anything that's marked the same shows you that those two segments are the exact same length. And we'll talk about that more about that here in a second. What do you think this letter is going to be? W. How about this letter? G. They tell us segment WG, that's this whole thing, is 7x minus 2. So I put that in there, label it. If you don't label these out, you don't draw these pictures, you'll never ever get this stuff. You'll never understand. You got to draw them. They tell us WG, or I'm sorry, WT, that's this part, is 3x plus 4. Well, what'd you tell me about TG and WT? So if this is 3x plus 4, what's this? Now can we set up an equation? Using the segment addition postulate, this plus this has to equal the whole thing. If you want, can you collect like terms before you write down this equation to make it a little shorter on yourself? Yeah, so when I go to add these two, what like terms do I have? 3x and 3x, what's that give me? 6x. So I put those two together already. Plus, what else? 8. Those two added together should equal what? Oh, variables on both sides. Does everybody remember how to solve this? What do you do first? Subtract what? Subtract the smaller x on both sides. Cancels out. You're left with 8 on this side. What's 7x minus 6x? 1x or just x. Add 2. Ignore that stray mark there. Add 2 to both sides. These cancel out. You're left with x equals what? 10. We could divide by 1. Stupid pen. We could divide by 1, but no real reason to, so we know x is 10. Are we finished? They also want us to find WG and GT. So we got to go back and plug in. WG, plug in right here. What is it? 68. 7 times 10 is 70. Minus 2 is 68. GT, how can we find that? Could just divide this by 2, couldn't we? What's that divided by 2? 34. Set them up. If you draw them, stuff isn't that difficult. Between, we already talked about collinear. If I'm going to find this distance from 6 to 11, what do I do to find the distance on a number line? Just count the spaces. 1, 2, 3, 4, 5. Let's skip over that. Write this down. That right there. Congruent. Very important that you know what congruent is. Construction is just a geometrical drawing. We'll talk about that later on in the year. Just so you know, construction is when you draw something. Congruent, very key in geometry that you know what congruent is. When I give you a definitions quiz here in a few days, congruent, the definition you can give me is same measures. If things are congruent, they have the same measures. That's all congruent is. Don't make it harder than it is. The congruent symbol looks like this. It's an equal sign. It's an equal sign with the little squiggle above it. We use congruent geometry instead of equals. Algebra uses equals, geometry uses the congruent symbol. Do what?
That's honestly a hard thing like when you do it.
What if I wanted to find the length from A to C right here? How could I do it? Count. 1, 2, 3, 4. So how long is segment AC? 4. What if I wanted to find the length of segment AB? Count them. When they're horizontal segments or vertical segments, horizontal, vertical, you can just count the spaces. How about if I wanted to find the distance from D to A, can I just count the spaces? It doesn't work. And we're going to talk about distance formula next time, how to do that. But on horizontal and vertical, you can just count. That's your assignment. Don't worry about the exit question. Just write down that assignment, page 16.
Is it gonna be on the
Probably, but I don't know when, because I'm sort of behind on my stuff right now. Parent forms, if you haven't got it in, get it into me. You're sort of lucky right now because I am behind. I haven't got grades in. So if you haven't brought that parent form back, get it into me. Calculator next time. I will have stuff caught up. Hopefully I'm going to get a bunch of it caught up today. But John's getting mad at me that my stuff's not all caught up. He's saying, man, you expect us to be caught up. Why are you not caught up? I'm going to get it today, John. No more me being behind. Hang on to it till I find your book. Because like I said, I think I did something with yours. If you have any friends, you might ask some of them. I can't remember my intervention or Orange 2 or what it was, but somebody said, I said, this is Colin's book. Does anybody have class with him? And they took it. John, is that your paper laying there by your desk? Have a good day. Make sure my rulers get back, please.